In this video, I'm going to illustrate the techniques you'll need to complete the empirical assignment for Chapter 12. As usual, I'll do that using a different data set. The particular data set I'm going to use is the one that's used for the examples in Chapter 12. And so I'm going to duplicate the third column of Table 12.1, where it does the extended example on how the price of cigarettes affects the quantity demanded. So you want to run the quantity of cigarettes on the price and some control variables, and then try to get the elasticity of demand out of that. The problem is, as we've talked about, this is a supply and demand system, so that price variable is going to be endogenous. So we're going to have to put in some instrumental variables for that, and then use instrumental variables regression. And then we'll do some other things like test for relevance and test for exogeneity. For this particular assignment, I will really encourage you to use a do file. Using the point and click, I think, is way too hard. So let me go through this example, and I'm going to post this do file so you can use this as a guide for your problem. You should be able to just amend this program to fit the homework problem. So let's go through it. So this first thing, again, this just tells it where the lines end. And so you have to put a semicolon at the end of every line. When you forget to do that, it'll give you an error message, as you invariably will if you do this enough. This just clears out all the old stuff that's in the program to make sure you're starting fresh. This sets up the log file like usual. I just named this Chapter 12. If you don't have this set more 1, as the output's coming out, it'll come down here with a little button that says more. You have to click on to see all of the output. This just stops it from scrolling like that. Then you read in the data in the usual way. Just put the path on your computer. This particular data is called sig12, sig_chap12.dta. And then it just sorts it by state and then by year. And that puts all of the 1985 variables at the top, sorted from A to Z, and then all of the 1995 variables at the bottom, sorted in the same way. The next thing is just a bunch of commands that generate the variables that I need to duplicate the 12.1 table. It's just a bunch of generate commands. This is the real average price of cigarettes, so we don't want the nominal price. We want to control for inflation, things like that. We do the same thing with taxes, generate real taxes. This is a cigarette-specific tax during the year, and you've got the total tax. The difference between those is the sales tax. And so there's a total price of cigarettes, and part of that price is a cigarette-specific tax, and part of it is a sales tax. The sales tax doesn't vary that much across states, though for some states like Oregon, of course, it does. But this cigarette-specific tax does tend to vary quite a bit, and it gives you a lot of price variation you can use to try to get that elasticity of demand. To get elasticities, we usually estimate a log-log model. So this is just taking the log of the packs of cigarettes consumed per capita, and this is the average, the real average price of cigarettes. And then one of the control variables we're going to use is income, and this is real per capita state income. So for each state, we'll get variation in income across states, and we want to make sure that we're norming it according to the population and controlling for prices. And then we log that variable as well. And don't worry about this encode variable. It doesn't do anything that you'll need. And then later on, we're going to need the differences in the variables between 1995 and 1985. And so here's a way you can do that. For instance, right here, let's look at this one first. This gen dr tax s equals this expression. One of the variables we created up here was r tax s right here. And we want the difference in that variable between 95 and 85. So the way you do that is just say D means difference. R tax S is R tax S, that's the current variable, minus R tax S n minus 1. And that will be the period before. And you can do that with the same variables. You could do this expression a different way. Remember, the log of A over B is log A minus log B. And so this is really the log of pack PC minus the log of pack PC at n minus 1. You can just write it as a fraction because that's how logs work. Anyway, that's just setting up all the variables. The only thing you'll need in your example is to take a log. So you're not going to have to do all this stuff. But I just thought I'd explain it anyway. Now, one thing you're going to need to do in your homework problem is add a bunch of dummy variables. There's year variables, year 1 through, I forget, it might be year 22. I can't remember the exact number. It's in the instructions for the homework. There's a month variable, month 1 through month 12. And there's 2 other sets of variables, some weather variables for 1 and some other variables as well. And there's a really tricky way, not tricky, but easy way to include all those variables at once. And so I thought I'd illustrate that. Actually, let me make sure. Let me just stop the program right after that command. So let me just copy these. If I put those there, it'll stop the program at that point. So we'll just get this part and not have to look at the rest. So what this R star will do, if you look over here on the right, you can see all of your variables. So it'll include in this regression the personal income variable that we created, the LT personal income. That's actually the difference. LT, that's the difference here, the log difference. And we want to include any variable that starts with R. So if we look over here, it's going to include R tax SO, R tax S, R tax, and this real average price variable as well. So it would include all 4. None of the other variables start with R, so it won't bring those in. But maybe I don't want this real average price variable. I just want these 3 tax variables. In that case, I could just say RT star, because this one starts with RA, it'll get excluded. And so when you're setting these up, if you name your variables in a particular way, you can pull them all in at once. Just start them with something consistent if you want them to come in as a group. Okay, so let me just show you how that works. Let me run this do file. And so you can see in the first case, it just ran a linear regression, and it included all 4 of those variables. Now notice something, and this is going to happen to you too. These 3 variables are actually perfectly multicollinear. And the reason is that, if you remember how it was created, where is it up here? One was just the difference in the other. It was up here in the generate. Where was it? Right here. Real tax SO is just R tax S minus R tax. So those are going to be perfectly multicollinear. And so it'll just throw one out automatically. When you include your year and your month variables, it's going to bring in year 1, or say month 1 through month 12. You can't have all 12 dummies, so you get multicollinearity. You have to throw one out. It'll do it for you automatically. And so don't worry about that. Same thing here. Now we said the command just use RT star, it only brought in the RT variables, and then it eliminated one of the variables to avoid multicollinearity. And so that's very useful. So you won't have to type, dozens or scores of variables. You can just pull them all in at once like that, and it's much easier. Okay, let's go back to the do file. And let me get rid of the, oops. Oh, and the other thing this did, remember what this R is? That just says robust standard errors. Okay, now we're going to run our first instrumental variables regression. So the command for that is ivreg. This is equation 12.16 in the text. And I'll explain this in a second, but this one does not control for fixed effects. And that's something we might want to do in this, and we can do that. You don't have to do this in your problem. Your problem's a little simpler in that respect, but I thought I'd show you how to do it anyway, because this is something we've looked at previously in the last chapter. Okay, so what we want to do is run the log. We're not using differences here. Later on, we'll use differences down here, and that's how we'll bring in fixed effects. But for now, we're just using the levels, not the differences. And we're only using the 1995 data. So this is a regression just for 1995. And we want to run the log of the the packages per capita. This is the endogenous variable, the price variable. And this is the way you tell it what the instruments are. So you just say the endogenous variables equals the instruments. And these are just control variables. There just happens to be one, the income variable. And again, robust standard errors. We always want to use those. Now let me note here, for your problem, you'll have three endogenous variables. So you'll have like something, and in that case, you'll need more than two exogenous variables. Yours will look something like you'll have one endogenous variable, then you'll have another endogenous variable, whatever its name is, LV2 or something like that, LV3. Or let me do it this way so it looks a little more elegant. Let me just copy these and rename them. Let's suppose we have three endogenous variables for some reason, as you might, and as you do in your problem. Then what you would do is include all three of them right here, just like this. Just list all three, because they're all going to use the same instruments. And then here you're going to need a bunch more instruments, because we're going to need at least three instruments for three endogenous variables. So I'd need like an x3 and an x4, or excuse me, let me just say exog 3 and exogenous. They're not exogenous, they're instruments. IV3, IV4, and so on. These are the exogenous variables over here. And so on. If there was IV5, if there were 5, these would be some name. They'd be variables from over here. You'd have a bunch more of them. Now we'd have 1, 2, 3, 4, 5 instruments for 3 endogenous variables. So we'd have 2 over-identifying restrictions. You'll have, in some cases, as many as 9 variables here as instruments and 3 endogenous variables. So just list the endogenous variables here and all your instruments here. Okay? So let me get rid of those since that's not part of our problem. Now let me stop it there and let's just look at what this does. So let's run this one. And you can see, oh, I left some variable in there. Oh, I left the 1 on it. So let's clear this. This is why do file is useful. Now I can rerun it just quickly by just correcting that silly mistake. And now we should be okay. Looks like we are. Okay, so here's the instrumental variable regression. It tells you it's a 2-stage least squares, number of observations, usual sorts of things. And here's the output. So if we wanted to look at the price elasticity of demand, we would just look at this coefficient here. And it's negative as we would expect. And so we're getting what we hoped we're getting. I didn't really explain why these are valid instruments. There's a long discussion in the book about that. I'll leave it to you to read. Just assume that they are, and assume the ones in your homework problem are valid instruments as well. But we're going to test for that in a couple of minutes. All right, so back to the do file. So that's all there is to running an instrumental variables regression. The variable on the left-hand side, the list of endogenous variables, the list of instruments, and the list of other controls and exogenous variables. I guess if we were up here, same thing. Now, what I'm going to do next is run the same regression. But what the book does at this point is say, we really ought to control for fixed effects because there's probably some variables that we need to control for across these states. And so we're going to control for entity fixed effects. And if you remember that taking differences when there's only 2 time periods is the same, including entity fixed effects. So what we're going to do is just difference all the variables, then run the same regression, and that should control for any of these fixed effects. And then we'll run the J test. after that. So the first thing we'll do is we'll run this regression, and then we'll run the J-test, and we'll explain how to do that. Well, I guess I'll explain how to do that right now. So this is the instrumental variables regression. The only difference between this one and this one, it was running in indifferences to control for fixed effects. That's not something you have to do in your problem, but might be something you have to do someday, and it might even be a good idea. In the problem we looked at, it's just not something I'm asking you to do as part of it. After you run the instrumental variables regression, to run that J-test, if you remember, what you want to do is run the residual from this regression on all of the instruments and all of the controls and exogenous variables. You can get the variables, they're just everything past the equal sign. In this case, it's just 3 variables. And so this is the way to create a variable that has the residuals in it. So this variable resid is created when you run the regression. I haven't done it yet. We haven't gotten to this point yet. And when it does, it'll name it E. So this is the name of the new variable here. We want it to be the residuals. You can put other names here. If you look at the prediction command and how to use it, you can put other names here. You can get the predicted values or different sorts of things. And then to do the J-test, you run the predicted values in the book. I believe it's UHAT on, as I said, the endogenous variables, the controls, the exogenous variables. Your list will be much longer because you have all of the year dummy variables and the month dummy variables and the other 2 sets of dummy variables that are in the problem. And you'll also have 3 endogenous variables, though the endogenous variables don't go in this regression. They're omitted. And so what you want to know is there any correlation between the exogenous variables, the instruments, and the error? If there is, that's not good. And so that would tell you that the instruments aren't exogenous because they're correlated with the error. And so we're going to do an F-test of that. We're actually going to do what's called a J-test. And the J-test starts with the F-test. So first we do an F-test, and that's done with this test command. And then the statistic is the number of degrees of freedom. In this model, how many is that going to be? It's going to be 2. Because that's the number of instrumental variables. So this is the number of instrumental variables right here, the total number. I believe in your problem this will be 9, but this will pull it in automatically for you. This RDF means that R just grabs the degrees of freedom from this regression. It's saved after the regression. This grabs the F statistic. And this is the way to get the critical value. The degrees of freedom on the critical value are the number of over-identifying restrictions. In this case, it's going to be just 1. It's going to be the number of endogenous, or number of instruments here, these 2 things. That's that RDF, minus 1. And so the degrees of freedom here, just that. And then this tells it to take the 95% confidence interval. And then this gives you the p-value. And so it says, give me the chi-square probability for this number of degrees of freedom, RDF minus 1. And this is the test statistic, the number of instruments times the F. If you remember, in your problem, the number of instruments going to be 9. And so the number of over-identifying restrictions is going to be 6. It'll be 9 minus 3 because there's 3 endogenous variables. In your problem, there'll be 3 endogenous variables, 9 instruments, and so that's 6 over-identifying restrictions. And the degrees of freedom, that's what this is for the chi-square statistic, is just that. It's the total number of instrumental variables minus the number of endogenous variables. And here it's 2 minus 1. And again, for yours, you'll have 9 minus 3. And I think it's a 90% confidence interval. I use 95 here. And then this gives you the p-value. So let's look at the output. Let me stop it here again and make sure it works. And here, see this resid variable, this E variable we created, and it tells us it's the residual, so you can check that over here. Okay, so here's the end of it. So here's the first instrumental variables we looked at before regression. Here's the one where we control for fixed effects. We're using differences. We don't get that much of a difference in the coefficient, a little bit. Standard errors, a little lower, a little bigger t, but it's significant. And then we do the J test to find out if our instruments are exogenous. And so we run the instrumental variables regression. We use that prediction command to grab the residuals. We run the residuals on the exogenous, or the instruments plus the exogenous controls. Here's the regression. Then we do this test. We grab the F statistic, which is 2.47. Then you take this is 2 times 2.47, which is going to give you this number, 4.93. This is rounded 4.94, you'd think, wouldn't you? But that's because there's rounding here. So you get 4.93. And then the critical value is 3.84, so you already know it's rejected. And so you get a p-value of 0.026. And so the hypothesis that these two coefficients the coefficients on these two variables are 0 is rejected. So that's not good news. We want those variables to be uncorrelated, unrelated to the error term, and it looks like there might be a little bit of a problem with the exogeneity of our instruments in this problem. You hope that it's not, that you failed to reject. Okay, let's go on to the final thing that you'll need. Go back to the do file. And let me get rid of this since we don't need it anymore. The last thing we need to do is to test for instrument relevance. And if you remember, that's the F statistic from the first stage regression. Now, an important note, important thing to remember, this test will only work when there's just one endogenous variable. If you have more than one, it won't work. In your problem for the homework, or the empirical assignment, there are 3 endogenous variables. So I've just artificially chosen one and said, let's pretend like, excuse me, let's pretend like this only has one endogenous variable, and then ask you to go ahead and do this instrumental relevance test. But it's not really a valid model because we're throwing out some things that ought to be in it. But as an illustration of how to do the test, it's just fine. And so the last part, problem 4, asks you to just pretend like there's just one endogenous variable so you can do this test. Okay, well, this test is pretty easy. What you do is take this instrumental variables regression up here, and you say, well, what would be the first stage regression for this thing? Well, the first stage regression is given right here. This tells you to run the endogenous variable, the price variable, on everything that follows it here. So we want to run as the first stage in the regression. Remember, we're trying to take out the exogenous part of the endogenous variable. We're trying to find the part of the price variable that doesn't depend upon the error term. And we do that by regressing it on things that don't depend upon the error term, which are these. These are uncorrelated with the error. And so The first stage regression that we want is just to run this price variable, the endogenous variable, on everything to the right. And then the test, what we want to do is test that these two, use an f-test for these two variables. So it's just a simple f-test on the first stage regression of the instrumental variables. Now, what are we looking for? Well, what we want is for the price variable to be correlated with the instruments. And the more correlated it is, the better. Because these are our instruments. Remember, they need to be correlated with the endogenous variable, but uncorrelated with the error. Well, if this F statistic is insignificant, that's the hypothesis that these coefficients are zero, that tells us it's not a very good instrument because it's not correlated with the price variable. So the bigger that F is, the better. Well, how big should that F be? The book gives you a rule of thumb that's saying if it's greater than 10, then you don't have to worry about the relevance of your instrument. But if your F statistic is less than 10, then you have a problem. And then you have to worry about finding more instruments or doing something about it. And we'll talk about that in the lecture. So let's run this and see how it comes out. So here's that very last regression. It's a linear regression. It's the first stage. You just use OLS on that first stage regression. And again, we just regress the price variable, the endogenous variable, on the two instruments and the exogenous variables. We do this test. The test if these two coefficients are zero. And it's 88.62. That's certainly greater than 10. And so in this case, we don't have to worry about instrumental relevance. But again, there does look like there's a problem with instrument exogeneity that we need to worry about. And that was that test we did before when we got the 4.93. Okay, just one last note. Up here, I'm not sure I talked about this enough, but these commands, these RDF and RF, I mentioned these. These are just variables that are automatically saved. We did something like this in the last example, the last do file, when we grabbed coefficients and did other things to calculate statistics. And these are just grabbed from the regressions. And these INV chi2 and chi-prob are just functions, and you can look those up easily. There's a whole bunch of statistical functions. You could do this for T or Z or F or all sorts of different functions. They'll have an F prob and an inverse F and so on. And so these are easy to find and use for whatever you're trying to, whatever statistic you're trying to find. Okay, well, good luck on your homework, and I will see you when we do this again.